Heyo, welcome back to Mr. Shaw's class. This video is brought to you by Superman. Superman approved. So we're talking about, in this one, inverse trig. Yeah, I know, I'm kind of giving it away. But in this lesson, this is the last new skill for the year. It is not the last skill in trig, but it's the last new skill in trig for this year. I was looking at this, the using trig to solve a side and right triangle practice. That's actually pretty good. Now, for this problem here, it's saying which trig ratio relates to angle Q. Once again, we have to look at what we have. What do we have? What do we know? What do we need? We know that my pen barely writes. We know SOHCAHTOA. What does that mean? Sine is equal to opposite divided hypotenuse. Cosine is equal to adjacent divided hypotenuse. Tangent is opposite divided by adjacent. SOHCAHTOA. What do we do with it? We look at what we have. What do we have? We have an angle. So I'm going to make this my reference angle. That would be step 2. Identify reference angle. Now, what does that mean? The reference angle is, well, we don't know what the opposite is until we know where we're starting from. If we're starting from here, draw a line. Oh, look, X is our opposite. If we were starting from here and we drew a line, Q, whatever this little section here is, would be our opposite. It's not. We're not. So let's do it the way we're supposed to right now. We know what this value is. Excuse me. We know what this altitude is. This altitude is X. We don't know what X is, but we know this altitude is X. We know the measurement of PQ is 10. So we have opposite hypotenuse. Opposite hypotenuse. What are we using? Sine. Step 3, let's trig. So if we're using sine, sine of 70 equals opposite over hypotenuse. If this were just any value here, let's say 2. 2 is equal to x over 10. How do we get rid of divided by 10? That's how we solve these problems. Sine 70 is a number. You can take your calculator like I've shown you in the past. Sine 70. It is a number. It is an unpredictable, irrational number, but you know what? It's still a number. Sine 70 is a number. It's a thing. It's something that we can manipulate. How do we get rid of divide by 10, multiply by 10? That leads us to right here. Solve for x. Sine of 70 is equal to x over 10, opposite over hypotenuse. We know the hypotenuse was 10. So all we have to do is multiply both sides by 10, so 10 sine 70 equals x. 10 sine 70. 9.396, well, okay, so 9.4. Oh, hundredth, so 9.40. You must have this 0 because it says hundredth. 9.4 is not the same as saying 9.40. Big difference. Because if you look, this is not 9.4. This is 9.396. 6 makes the 9 round up, but significant figures, it makes a difference. Especially if you're building a bridge. You don't want to have a rounding error building a bridge. Alrighty. We can find the measurements of the other angles in the triangle. So if we isolate just this, we know this is 9.40. If we know this and we know this, didn't we say that sine 70 is a number? If this is a specified number specific to this side and this side, there is a way to find this specific number. Now, I can talk to you about something called a trig table, and I will post a picture of it in my classroom, but trig table's crazy. That's how I learned to do these, and that was when these were first starting to become popular in schools. Trig tables are crazy and ridiculous and pointless. They were great if you wanted to do trig without technology. They'll be great if we ever have an EMP and we're back in the Stone Age. I'll whip out my trig table and still be able to do trigonometry and teach you this stuff. Excuse me. Back to this. Which trig ratio relates to angle R? So what we're doing is we're setting our ratio, our reference angle. Remember how we said look at what we have, identify the reference angle, and then trig? I'm going to do slash inverse trig. That's what we're doing today. Like I told you, I already gave it away. So from here we have draw a line. That's our opposite, hypotenuse. Opposite hypotenuse, sine. We're still dealing with sine. Sine of R is equal to 9.4 over 12. So when you do the solving for an angle and right triangles, it's going to introduce inverse trig. When you're using your calculator, I posted a video, refer to that if you don't know. If you have an Android, you can get this just fine. If you have an iPhone, I'm sorry. Sorry, I'm getting out my calculator on my phone just to show you once again how great Android is. Maybe I should get them as a sponsor. See? Oh, pretty. Oop, there's my notifications. Pretty, right? That's my cell phone. That's my calculator. I like it. It is Superman approved. But getting back to the real calculator. So if sine of x is equal to 0.3420, what is the measure of angle x? It is so hard to do this. Let me show you how hard this is. Sine of x is this. What is the opposite operation of sine? Sine is an operation. Cosine is an operation. Saying sine of something is like saying 4 plus 4. That plus is what sine is. So how do we get the opposite of sine? If you can take a look, you know, right there. Sine to the -1 is the opposite of sine. Second, sine, ready for this? This is so difficult. 0.3420. Done. That's my degrees. So difficult. So what is the measure of angle R? We know that R was 9.40 over 12. We're using sine. Second sine. 9.40 over 12. Close it. Enter. It's a 51.57 degree angle. 51.57 is not the right answer. 51.57 is wrong. Degrees is right. Yay! Moving on. Now, number 10, I hate. I'll explain. What is the value of df? How do we find this? You can use trig, but we don't know this. What do we know about all right triangles? Some ancient Greek dude. Pythagorean theorem. A squared plus b squared equals c squared. Now, how do we undo this? If we don't know our a, why is this a? Because I said so. It doesn't matter. The only one that matters is that this is the hypotenuse, so that's always c squared. How do we get rid of a if we don't know a? I mean, how do we isolate a if we don't know a? Well, how do we get rid of plus b? A squared is equal to c squared minus b squared. Oh my goodness. Simple math. Simple math. What is the opposite of a square? Square root. So a is equal to the square root of c squared minus b squared. Now you're going to say, Mr. Shaw, what if it's negative? Two things, people, two things in this universe cannot be negative. I'll tell you one thing, money can be negative. Most everybody you know, money is negative because of credit cards. So money's not negative, or money can be negative, I should say. Time, distance. Isn't this a distance? When we do this, we are automatically, no matter what, always going to take the positive number. So let's do this. C squared, 8.5 squared minus 6.5 squared. 8.5 squared minus 6.5 squared. This is so difficult. 30. I can break down 30 as being the square root of 2 times 3 times 5, which doesn't do anything to help. So it can either leave it as a square root of 30, or I can do square root of 30 and get a decimal value of 5.477. I'm just going to leave it as square root of 30 is approximately equal to 5.48. What trigonometric ratio that relates to angle D? Okay, so we're talking about angle D. Side EF and side DE. So, draw my opposite. Has nothing to do with the question. I'm drawing the opposite. I always draw my opposite. Opposite. Oh, that's the one we have. Hypotenuse. SOHCAHTOA, 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 SOHCAHTOA. Okay, that's the extent of my vocal capabilities right now. Sine is equal to opposite over hypotenuse. Sine of angle D is equal to 6.5 over 8.5. So when it's saying what is the measure of angle E? Oh, I didn't like 11, sorry, not 10. The trig ratio that we're using is not sine. Sine of D is equal to 6.5 over 8.5. 8.5. So how do we get rid of it? What's the opposite operation of sine? Inverse sine. If you were to do it out step by step by step, without skipping any steps, this is what it would look like. You are applying an inverse sine to this. Inverse sine cancels out sine. So we're left with D equals inverse sine of 6.5 over 8.5, inverse sine of 6.5 over 8.5. How did I get inverse sine? second sine. If you have an Apple iPhone, guess what? There's an inverse button, second, I believe. If you have an Android calculator app, it's an INV button. 49.88. Now, determine the measure of angle D without using the trig ratio. Oh, this is D. Okay, folks, make sure you read your directions. What is the measure of angle E? Not D. So, let me just redo this real quick. We can use that to check my answer in a minute. We're talking about E now. See that I got messed up because it's asking D here. So E is adjacent over hypotenuse. So we're using inverse cosine. Inverse cosine of 6.5 over 8.5. Why is it 6.5 over 8.5? Because cosine is adjacent over hypotenuse. 40.12. You would just do cosine here, cosine, cosine, inverse, cosine, okay? And you get E, angle E is equal to 40.12. Determine D without using trig. So find D without doing this. My problem is you can't. Now, what they want you to do is say, oh, you can just take angle E, 40.12, and subtract it from 90 to get 49.88. That's great. But guess what? How'd you get 40.12? How would you find this without using a trig ratio? To be quite honest, their answer is 180 minus 90 minus 40.12. That's what their answer is. That's what they expect you to say. To be truthful, you would get a 6.5, let's say, inch piece of paper, 8.5 inch piece of paper, and you would make it so that these ends are 90 degrees, like this side here is 90 degrees this side, and then you go and you measure this. That's the only way to find out that it'd be about 40 degrees. You wouldn't ever get it 40.12 unless you had a, I don't remember the name of the tool. It's a special type of protractor. It's a digital protractor that goes around it. I can't remember. Sorry, guys. But, yeah, that's something that you would be using if you were an architect. Which, people make a lot of money. We're done. I will see you next lesson. Bye.